This recording is on the usage of PyProfiler software for Scanning FCS modality. And here, this Scanning FCS is developed for users who do not have any possibility to record point scanning single particle profiler on their microscopes. So the solution can be to record the line scan and then analyze this line scan as Scanning FCS. Again, here I will launch the already prepared standalone distribution. In the video description, you can find how to install standalone distribution on your computer. Especially this would be relevant for Mac users because the standalone distributions should be created with the same operational system as it should be executed. So sometimes it is required that you install it on your own. When you have your standalone distribution already installed, you can just launch it, and it takes some time, especially when you launched it the first time. Okay, here is the software, and you can see that in addition to single particle profiler tab, you have several more tabs. I will start with this tab, which is called Scanning FCS Carpet. And here, exactly, you can have the Scanning FCS image, and then you can select traces on that image. So I will launch the importer, and here I have the ND2 files recorded on the Nikon system. So we can select one of those. You click open, and I will have to wait a little bit until this file will appear over here in the list of imported files. And then the SFCS image will appear over here. It has already appeared. And here you have other things that are extracted from this image. So what this image actually is. Over here, you have 64 pixels scanned. And here is the time dimension. So pretty much this one line was scanned over and over with the lowest possible time step, which is indicated over here, which is 0.002 seconds. This is the time step between the lines. And this you have to put in manually. So you would need to know what is your time step to put it in here. Then what is going on here, you can select the line, and from this line, the trace will be extracted. Let's say right now the line is put automatically just in the middle, but what you can do, you can select the line, let's say over here. And now this line is selected. So you can see that traces are present in both channels. Here only one channel is displayed, but extracted channels are in both. And in addition to the uh, intensity traces, the correlation curves are extracted. So autocorrelation curve for channel 1 and for channel 2. No, other way around. So this blue is channel 1, the orange is channel 2. And the cross-correlation channel, cross-correlation function, they are both extracted and they are displayed over here. This is autocorrelation function for every line over here. So in principle, if you do not want to choose your line from here, you can also choose your line from here. Let's say you want this. Obviously, that over here you have something bright coming through. So this was some large aggregate, which is yeah, not very useful probably for our analysis, but for example, it yields very intense correlation curves over here, and you will see how it looks as well. So we can choose over here. So you can see that here was this patch of garbage that was wandering through the observation volume, and you see that correlation curves are according to this big object that was traveling through the focal point. What you can do next, if, for example, you want to, you are not satisfied with the signal that you have over there, you can also bin your pixels over here from this image. So here, what you can do, you can also increase the pixel binning, which is over here just one. That's why you have 64 lines over here, because that's how the image was recorded. So let's say you want to integrate two pixels together. So in principle, you will have the 32 by, I don't know, 100 something seconds, but you will want to have 32 pixels over here. So we can go here to the pixel binning 2. And the moment you activate it over here, it will start processing. And then eventually you will have your image, which has now 32 pixels over here. And again, you can, by clicking over here, display different traces. Of course, here you lose some spatial resolution, your observation volume becomes bigger, but especially for the dim samples, this can be a nice solution if you want to continue using your line scan as as the solution for SPP. Okay, let's say you chose the settings as you prefer. We can go also back to pixel binning 1. And now you want to proceed analyzing your traces from over here. So pretty much what you need to do, you need to transfer the data from this tab, which is Scanning FCS Carpet, into this tab. So single particle profiler is the main tab in which the analysis will be done. So let's say, I don't know, this middle trace over here looks not bad, so we can proceed with that. So you can click over here, transfer curve, and now this curve appears already here. So you can click over here, and now you see your curve and your correlation curves already in this window. You can click Peak Analysis, and then you can proceed with the peak analysis exactly in the same manner as it is explained in the other videos. Please find some links in the video description how to analyze further. Of course, here you will also see the parameters of your extraction. So you see binning is 1 and number of line is 32. If you want a different line, you can also come back over here and select, let's say, this line. And then you can click transfer curve again. And now what you are going to have when you go again to peak analysis. Yep. So you can see that you have now two traces over here. One is from line 32, another one is from line 45. In exactly the same manner, you can change your binning and select completely different line, and you will have one more file which will say, let's say billion 2 and number, I don't know, 14, for example. And then you can proceed with this and you can save your data and go on with your measurement.